Good morning, ladies and gentlemen. I'm going to try to get through this as fast as I possibly can. I very much apologize for the length of most of these videos this year. There's just no easy way to do it. It's kind of a pain in the rump. But we are continuing here with our integration or the rectangular area approximation, which are Riemann sums, very important term in calculus. And to review a little bit from yesterday, some of the quantities we needed to calculate a Riemann sum, we had our function f of x over here. And what we are doing is we are finding the area between the curve and the x-axis between some interval from a to b. And they can be decimals, they can be integers, it can be zero. I mean, interval can be anything. And what we do is we break the area up between a and b into n rectangles. And they tell us how many rectangles to break it into typically. And as we break them in there, okay, then we need our counting mechanism, which is k. Okay, k is our counting mechanism, and it tells us what rectangle we were on. So if we break this in here, think of this right here again as my kth rectangle. And when I'm finding the area underneath this curve, okay, bottom line, they are rectangles, guys. And so the area of a rectangle is base times height, if we can think about this. And the base, or the width of my rectangle, is right here. It's my delta x sub k. That's the width. And we are keeping all of these widths of equal width, so we have nice, easy calculations. Well, that gives me the width. And what I need to do is I need to pick an x value within my subinterval, okay, within the width of my rectangle. And we are going to pick nice points. We are going to pick left, right, or middle. And in this case, my c sub k was a right endpoint. And because this is my c sub k, how we actually find the height of the rectangle is we plug that x value into our function, and that gives us our y value, or our f of c sub k. So in order to find the area of that rectangle, we take the y value, okay, the height of the rectangle, times the x value, which is the width of the rectangle, and that gives us the area of the rectangle, and that area approximates the area of the subinterval in which we are talking about. And the more rectangles that we pack in our interval from a to b, the more rectangles we pack in there, the better our estimate will become. And once we hit an infinite number of rectangles, we will have a perfect exact amount of area, but we're not there yet. So after we have all of the areas of our rectangles, okay, remember in Algebra 2, they really got into a sum. And the sum, so if I take all the y's times all the x's, all the rectangles in there, and I find the sum of them from my first rectangle to my nth rectangle, well, this is what my Riemann sum looks like, okay? This is, remember, this is triangle, this is rectangle number 1, this is number 2, this is the area of number 3, this is the area of the last rectangle in our subinterval. Well, then if you look at that, because we're being crafty, because we're being smart about this, we're making our calculations easy. Remember I said we are keeping all of the widths the same. Because all of those widths are the same, we can factor that width off each one of these rectangles. And bottom line, what we end up getting is we get the width of the rectangle times the sum of the heights of the rectangle. Oops, better put a bracket there. And that approximates the area under our curve, okay? And hopefully you kind of followed what we did yesterday. And what we're going to do today is we're just going to do a couple more examples. I'm going to do everything calculator driven here to make our calculations to try to get this video to the point of this video better. So bottom line, this should be the next example in here. And what we're doing, here is our f of x function. Okay, f of x is 6 minus x squared. And we want to find the area underneath this interval from 0 to, let's say, here is my 2. And we want to break that into 5 rectangles. Oh boy. Well, remember, b minus a divided by n will give me the width of my rectangle. So that's like 2 minus 0 over 5. Well, that's 2/5. That means each rectangle width is 0.4, okay? Well, that doesn't make things nice because now I got to pack I'm packing 5 rectangles from 0 to 2, and here is my 1 right here. And actually, I got to make this a little bit wider because I'm packing the rectangles. I want to see them. I'm going to throw my 2 way the heck over here, which is going to put my 1 right here, okay? Now, if I'm making the width of each rectangle 0.4, well, here's a half, here's that. Well, that doesn't make things easy for me, but think about this. If I'm using a left endpoint, okay, my first endpoint is going to be here at 0, so the width of the first one, that's going to take me to 0.4, which is going to be right about here, right? So there's one rectangle, there's 0.4. The next one, if I add 0.4 to 0.4, my next one's going to be about 0.8. So that'll be my next rectangle. And then if I add 0.4 to 0.8, I get like, 1.2. And that's 1.2. And if I add 0.4 to that, I get 1.6, which is just a skosh past my half. And that's 1.6. And if I add 0.4 to that, well, then I get to the 2. Remember, if I'm using a left ram, I am using the left endpoint of each interval in there. So all of my rectangles are, the left endpoint is the top. Okay? So I am finding the area of all of these green because my left endpoint, so 0 is my first one, and I'm finding the area of all of these rectangles. And you're going to put a couple things together before the end because my function is decreasing across my interval in this case, and it's concave down. This is going to be an overestimate. Well, how do I do that? Well, bottom line, if I took all of these, I'm taking the width of my rectangle times the sum of my heights. Well, how tall is this first rectangle right there? Well, the height is dictated off of f of 0 plus, what's the height of my second rectangle? That's going to be here at 0.4 because that's the height that's on my curve. F of 0.4 plus, the next rectangle is going to be 0.8. F of 0.8 plus, the next one's f of what? 1.2 is it going to be, I believe? 1.2 plus, so that gave me this rectangle, plus my last one is f of 1.6. My calibration's off, but it doesn't matter. Okay? And notice I wanted 5 rectangles, therefore I have 5 heights that I am summing together within my parentheses. Now from here, I'm not going to kill myself finding all of these out. What I'm going to do is I'm going to grab my calculator. Oh, wrong one. My calculator. And I've already defined f of x in there in my calculator page. So how I want to do this, and I'm just going to do this a couple times, do this once because you should know how to do this because you've done it. We are going to take the width 0.4 and we are going to say you are times by f of, my first height is 0, plus f of, my next height is going to be not 0, it's going to be 0.4, plus f of 0.8, plus f of 1.2, plus f of 1.6. And that's all I'm going to do today with these, and I'm going to plug all that in, and I'm going to let the calculator spew it at me rather than go through all the mental math here. And I'm going to hit enter, and it looks like my left ram my left ram is going to be 10.08. Okay, so my left ram with 5 subintervals, that's important because if I have more than 5, I'm going to have a different one, is going to be 10.08, and that is the area. Okay, so what I'm doing is now I'm going to be finding the right ram in the next problem. Well, just for the ease of looking at things, so if I'm using my right endpoint now, well, now that would be using 0.4 for the first height of my rectangle, and I'll find that one, and then I'll use that right endpoint to find that one, and I'll use my right endpoint in this interval to find that one, and my right endpoint again to find that one, and my right endpoint again to find that one. Notice all of these fuchsia-colored rectangles, they are under the curve, therefore this would be an underestimate. And what am I going to just go slam into my calculator? And that's exactly what I'm going to do here, guys. And I'm not even going to go to my next slide to find it. I know all of these, they all have a width of 0.4 times, well, my first one is f of 0.4 plus f of 0.8 plus f of 1.2 plus f of 1.6 plus f of 2. And when you look at this, check it out. My left and my right sum. Well, what I did from my left ram to get my right ram of 5 in this case, bottom line, all I do is I throw out the first functional value that I had and I add the last one in there. And notice all of these other ones are still in there. Okay, all of those were in there, but I threw out the one way on the left and I added the one way on the right. Otherwise, because these are the only endpoints that are going to possibly change for me between a left ram and a right ram. If I'm starting with the left, I start with my left endpoint and I just add my width to the function each time. If I'm doing a right ram, I'm going to start with the right endpoint of the first interval and then add my width to each one to plug into my function. And I would go straight to my calculator because my function is already defined in there, and we are going to find that the right ram of 5, actually the right ram is going to end up equaling 8.48. Did I get the right one? I think I did get the right one. Okay? And that would be my right ram. Well, what we're going to do now is we are going to go back and do the mid ram. Okay, and I'm going to do a whole new picture here for you for my mid ram. In my mid ram, my function's still going to be the same. It's still f of x equals 6 minus x squared. We are still going to be on the interval. What interval are we on? I can't even see my page anymore. We're still on the interval from 0 to 2, and we still are going to use 5 rectangles. So I'm going to hit pause, I'm going to redraw, and I will be back. I just want to come back here because before I draw this whole thing, I know I'm doing between 0 to 2, I know I'm doing 5 rectangles. I don't even need anything on my x-axis right away because a lot of people get hung up, how do I draw it, how do I draw it? Just make 1, 2, 3, 4, 5 rectangles in there, okay? And we don't know what these x values are, but we do know if our interval starts at 0, we start here, we know our delta x is 0.4. Well, if I add 0, that's going to be 0.4, and then the next width is 0.8, 1.2, 1.6, then to the 2, and I should have an equal amount of rectangles between there. Just because they're decimals, don't freak out, okay? And now I'm going to draw these in really quick. Here, and here, and here, and here. My width is all the same. This time we're doing a mid-ram, right? Well, now I'm using the midpoint of each one of these triangles, of each one of these rectangles to make one that's over and one that's under. And I got to use the midpoint to come up. Some's going to be under, some's going to be over. Midpoint's going to come up. And why am I drawing all these? I'm drawing all these because we need to be able to find out what these x values are to be able to find the height of each rectangle. Well, because it's the midpoint. Well, bottom line, I know my mid-ram of 5, I know that's going to equal the width of 0.4 times all my heights, f of. But what is my first height? Well, I'm the midpoint between 0 and 0.4. I guess that would mean this is 0.2 plus f of. Well, how far is midpoint to midpoint? Hey, midpoint to midpoint, if I have equal width rectangles, they are all 0.4. So that's obviously going to be 0.4 beyond 0.2 to 0.6 plus f of. What's the next one going to be? Well, add 0.4 to 0.6. That's f of 1 plus f of 1.4 plus f of 2. No, 1.8. Man, I'm just trying to get this thing done too fast. F of 1.8. Now, if you don't know if you have enough, I have 1, 2, 3, 4, 5 rectangles in there. Next thing I'm going to do is I'm just going to go straight to my calculator because, again, my function is defined in my calculator. I'm going to type in exactly what I see right here. Hopefully you're doing that. You're going to find out your mid-ram of 5 is going to equal 9.36. Okay? And the more rectangles we pack underneath there, the better estimate we get. Hopefully you can see the mid-ram, the midpoint estimation is much better than the left or the right in this case because I get a little under, I get a little over, and it just gets a little bit nicer. Okay? A couple more quick examples. Here's just a different one. Well, we don't really need a picture, but if we did do a picture, hopefully you remember the y-intercept. This is going to be here at 1. Okay, that's 1. This thing's going to be concave up, and it's a parabola. So I'm just going to make my thing come up, and I am trying to find the area from 1 to 4, and I know I want 6 triangles in there. Well, if I need 6 rectangles in there, I need to know what's the width of each rectangle. Well, the width of each rectangle is b minus a, so I got to take 4 minus 1 and divide it by 6. Well, that's going to give me 3 over 6. So the width of each one is 1/2, okay? Don't kill yourself trying to figure out what the x-axis is. Well, I need from here to here, I need 6 rectangles in there. Well, I'm going to go here, I'm going to go here, I'm going to go here, and I'm going to make 6 of them. Because the axis is easiest to get, okay? Well, if I'm adding 1/2, well, this one is going to be 1.5. This is going to be 2. This one's going to be, right there, is going to be 2.5. This one's going to be 3. This one's going to be 3.5, right? So those are all my endpoints of my triangles. If I'm finding a left ram, and before I do this, I am going to go just like this. And I'm going to go edit. Copy that for my next one, okay? If I am finding my left ram, that means the left endpoint of each one of these intervals, the left side is going to be making my rectangle. And the edge of the rectangle in which intersects your function is the value that actually gives you the height. So it's pretty simple usually to track. 1, 2, 3, 4, 5, 6, 7. Ooh, something's not right there, isn't it? I just drew 7 rectangles in there. Huh? Let me back up and start over because oh, no, I didn't. You bonehead Kruger. We're doing that because this is not a rectangle here. Okay? Our interval is only within the pink here. So there's 1, 2, 3, 4, 5, 6 rectangles. Okay. So my left ram, remember, left ram is going to equal width times sum of heights. What is my width? 1/2. times. What are my heights? Well, track it. There it is. It's the right endpoint of each interval. So I need to take f of 1 plus f of 1.5 plus f of 2 plus f of 2.5 plus f of 3 plus f of 3.5. And I should have 1, 2, 3, 4, 5, 6 rectangles in there. And then I'm just going to go redefine, because this is now a new function. I'm going to redefine this brand spanking new function in my calculator. Hopefully you remember how to do that. And I'll do it one more time, but I don't want to waste all this time on the calculator stuff that you should know. Remember, we're going to go Menu, Actions, Define, and you define it as f of x equals 0.5x squared plus 1. There, it is done. And then you take your function and you say, okay, what is 0.5 times parenthesis f of 1 plus f of 1.5 plus f of 2 plus f come on. And we hit Shazam, and we should come up with 11 point, remember, 3 decimal places, 11.688. And I'm not putting units on there because I don't know what my units are because they didn't give me units for the x or the y-axis. It's the area. That is correct. If you want to call it units squared right now, that's basically what it is. Well, we're going to come to the right ramp. The only difference now is, come on, baby, work for me here. Hey, son of a biscuit. Lay that old girl right on there like that. And I'm going to turn it off. And because we're doing the right RAM now, well, now all my endpoints are used on the right side, which means I am going in overestimate this time. Okay, my last one was an underestimate, but notice the concavity and the increasing, decreasing of this one has changed. Therefore, this is an overestimate now. And what I got to do is I got to take my width of a half times, this is going to be my first one. Now I drop the first endpoint, 1.5, plus, and I add the last one. Okay, and now, because what the right endpoint does is when I'm using the right endpoint, now here's my first functional height, here's my last functional height. When I'm using the left endpoint, my left is the first one, and my second to the last is the last one. And they just alternate. And when I do that, I find out my right RAM of 6 is going to equal, hopefully you're typing this into your calculator, hopefully you are pausing to try to do some of this stuff, 15.438 is what I came up with on that one, I believe. And what I would like you to actually do now is I really would like you to hit pause and give this next one for the mid-RAM a try on your own. And I'm going to edit, I'm going to paste mine in there, I'm going to grab this, I'm going to try to, come on baby, try to lay it right on top of the other graph. Because now remember, okay, still 6 rectangles, except now this midpoint, that's making my rectangles. So now that I know this first midpoint and I know my delta x is a half, it's pretty easy. I don't need to draw every one of them in there, okay? So why don't you give it a shot here, and I'll be right back. Okay, so now that we're back, obviously, if we're using the midpoint here, ladies and gentlemen, obviously, what's the midpoint between 1 and 1.5? That would mean my first one is 1.25. And then notice each c sub k value is exactly 0.5 away, 0.5 away, because we are keeping our interval of equal width. Therefore, it's easy to find all of these, and you don't have to kill yourself trying to lay it out. If you know the first one, okay, you just keep adding your width to find the next midpoint. Add your width to find the next midpoint. Okay, and then you plug them in. I'm never going to have you do all these decimals and really disgusting things without a calculator. So you type it in, you get the mid-ram is 13.468, hopefully. Okay. So the next one we're going to do here is kind of an ugly little function. Okay, you know, this is one where it's like, oh boy, I've never seen a function like this. Do you know what the parent graph looks like? I know, I've been harping on that a lot. And yeah, no, don't really know what this one looks like. So what would you do? Hopefully, you would grab your calculator here, and hopefully we would try to graph this little rascal. And this one looks like it is what? Cube root of x squared minus 4. And it's like, whoa, that is a wonky looking little critter. And come on, let's get rid of this thing here. I'm going to delete that. No, I don't want to. I got to pause again. Okay, so basically we have kind of a wonky looking graph here. And what I did as I paused is I took this little bad boy. Sometimes you really need to kind of see the graph to see what you're looking at, and this is kind of a goofy one. Hopefully you can look at this, okay? And if we are using the right endpoint, hopefully I hope you can picture in your mind that we will be doing an underestimate. And if we use, the left endpoint will be an underestimate. The right endpoint will be an overestimate. Hopefully you can kind of picture that here. And what I did was I came over here. Well, here's my function. There it is. Can you see it? I can see it. And what we need to do is we are going from 2 all the way up to 12. Okay? And we are breaking this into 5 rectangles. Well, how do I do that? Well, my width is always b minus a divided by n, or 10 over 5. Each rectangle width is 2. So if I know my first one, if I'm looking first for my left ram of 5, okay, I know my width, my delta x is 2 times f of what? Well, if I'm using my left endpoint, it's going to be f of 2 plus f of, what's the next one? Well, width is here. That's going to be 4. F of 4 plus f of 6 plus f of 8. Notice all I'm doing is I'm adding my width to my functional value, f of 10, until I have achieved the number of rectangles, 1, 2, 3, 4, 5, that I have. And there it is. So bottom line, and I said the left endpoints are going to give an underestimate, because here's the height of my first one, here's the height of my second one, third, fourth, and fifth. And I can see the area of the first one, 0, plus, I don't know what this one is. The height of this one, I actually have to plug 4 in here. So I would go straight to my calculator. I would plug that in, and my left ram, hopefully you found out, is 27.916 units squared. What I'd like you to do is I'd like you to hit pause, find the right ram and the mid ram of this little dirty dog, and I will be back with the answers for both of them. Okay? And again, like I said, the right ram was going to be an overestimate, And once you get this figured out, hopefully you've caught on to the pattern. When I'm going from left ram to right ram, all of these stay. All I do, coming, see how all of those stayed in there. I get rid of the first one, and I add the last endpoint, and I type it into my calculator. Okay? Hopefully you have the mid-ram. I'll be right back. Okay? And if you come back through, if we're going from, again, from 2 to 12 into 5 rectangles, which are where the blue lines divide them out, use the midpoints of each one. 3 is my first functional height. Then I go 5, 7, 9, and 11. And what that does is that brings me to my width times the sum of my heights in function form dumped into my calculator. The mid-ram is 34.342. Okay? And that should get us there pretty close. This stuff I'm going to skip because I do not have this loaded on the particular desktop that I'm recording from. And it's fine. It doesn't really matter. I can show you how to use it sometime in class. It is on your handheld calculators. And where is it? It's if you go to your menu, where do you have to go? You have to go to, you're going to go to your menu. No, you got to go to your home page. If you go to My Documents, and I don't have it, but underneath your downloads, you're going to hit your downloads. Okay, and in that downloads, or you're either, no, you're not in downloads, you're in transfers, I'm sorry, and look for 1-27-20, and underneath that little folder, there is going to be a Riemann Sum program for you, and it kind of describes, there's 3 tabs, it really does describe what to do here, because we can load it in, we can find the right ram, left ram, mid ram really fast where n is 100, 25, 50, or 10, 25, 50, or 100, or anywhere in between. There's sliders. Go in there and find it and play with it. Last thing I want to do is I want to try to talk our way through here an old AP problem. AP problem. Okay? And this is like a free response, and this is a table of values. They're not giving us a function. They are giving us data values here. And oil is leaking out of a tanker damaged at sea. Damage to the tanker is worsening as shown by the increased leakage each hour recorded below. Okay, so what they did is they gave us particular times in hours and the leakage in gallons per hour. So that's a rate. Okay. And they're telling us how many gallons, and those are instantaneous rates right there. So like at time 4, the 4-hour in, right there at that instantaneous moment in time, it's leaking at 190 gallons per hour. And then it keeps increasing. So they're not giving us a function, they're giving us data values. And they're going to make you do this on the AP test. And they're going to make you do a left sum, a right sum, a mid sum, a trapezoidal sum, whatever. And what they want us to do is they want us to give an upper and lower estimate of the total quantity of oil that has escaped. Well, by AP time, most people get all wound up and figured out, oh, what do I got to do? I got to do an integral or do I do a derivative? And what I would recommend you to do is focus on your units, because what they are telling me is here's my hours, because that's my x-axis, and this is gallons per hour, okay? And as I think about this, okay, integrals or sums or area accumulators, what did we do? We multiplied base times height. If I multiply an x times a y, notice I'm going to get gallons. And that would be a quantity of oil that has escaped in gallons. So this would be an integral. If they're asking me for a rate of change or something, hey, that would be a derivative for the most part, but not for sure. Okay? So how am I going to do this? Give an upper and lower estimate for the total quantity. Well, once you get better at it, you're going to be able to see what it is. Well, this is increasing. What I would recommend you to do is go from 0 to 8, and 4 is going to be in the middle, and 2 is going to be in the middle. I'll have a 1 and a 3, and 6 is going to be in the middle, 5 and 7. And try to picture what your graph looks like, okay? Because they want us to find how much oil escaped after 5 hours. So if I tried to graph this out, well, man, I got to go up to 720. Well, I'm going to throw like 700 right here, which means right in the middle of that would be 350. And if I kind of went a little bit underneath there, I'm going to call that 300 maybe, 400. And I need this here a sec. Oh, sweet. And this is going to be 500. And this would be 600, which is going to take me to 200. Oh, 100, got a big jump there. And what oh, son of a biscuit. And what I'm trying to do is I'm trying to kind of plot my data points that I have here. I'm going to make them in fuchsia again. I'm going to go like 0, 50, and 170, so it's increasing. And then 97, and 136, somewhere in there, I don't know. And then 4 is just under 200. I'm making my dots looking too linear here, but it's not the end of the world. Bring those down. I'm going to bring this guy down a little bit, because it's, come on, somewhere in there, I don't know. But pretty quick, you're going to see what's going on. We're at 5 is 265. We go a little higher, and then 7 is 5. Wait, 6 is just about 400. And 7 is 516. When it really starts coming out. And then 8 is way the heck up here. So you can basically see it's not linear. Well, you can connect those dots if you want. You can picture it as a function. And bottom line, if they want an upper and a lower estimate, upper estimate is over estimate. Lower estimate is an underestimate. Okay? So if I'm thinking about this, and I know I have to take hours times gallon per hours to do this, my upper estimate, notice how nice they were. Notice I have nice incremental changes, and I'm supposed to find it from 0 to 5. And I notice it's really nice. I don't know any data values between 0 and 1. So each interval is going to be 1 hour wide. And if they want an upper estimate, I am looking at rectangles that look like this. I should have gone the other way here. I'm sorry. I got 1, 2, 3, 4, 5. Now I really need to define, that was the point, that was the point, that was my data. Because upper estimate is basically, not basically, if I tried to connect this somewhat function coming up, and here's all my data points so I can see them all. An upper sum is an overestimate. So all I would really need to do is say my width is 1 times the sum of my heights. Now watch. If it's an overestimate, this is a right endpoint estimate. Therefore, I take the right endpoint, which means I'm going to look past that, and I'm going to take it all the way. So I got 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles, 5 rectangles. I'm using the right endpoint. So I'm going to say 70 plus 90 plus 136 plus 190 plus 260 5. And that's going to give me, because that's what it is. The height at 1, the height at 1 is 70. So these are my areas of my rectangle. Well, I should say the width is 1, so I can't take that times 2. I don't want to kind of wonky you out with that. But my width is the differences in my x's. My height is my y value. So if I added those all together, took them times 1, 758 gallons, because yes, I did multiply them. I'm taking hours times gallons per hour, which cancels out, and I'm left with just gallons. So my under estimate, or my lower, I guess I should call it my lower estimate, not my underestimate. All right, I'm going to make it red. I'm going to say lower, or my underestimate. Well, that means I'm starting with my left endpoint, because then I'm saying, okay, well, the left endpoint is going to get me to here, and that's where my 5 rectangles are coming from. Notice I throw out the last one in this case. I'm throwing out the last one, and I'm taking 1 times, and I'm adding in the first one, plus all the other ones that were there. That, come on, Kruger, which I should have 1, 2, 3, 4, 5 rectangles for 5 hours, and this is going to be 543 gallons. Okay, well, how about after 8 hours? Well, now that just means I got to sum 1, 2, 3 more rectangles, okay, for an upper and a lower. And let's see if you can have that. Okay, so notice if I need to go after 8 hours, there's no sense in adding up those first 5, because I know what those first 5 hours are. I found it in part A right here in that upper sum. So all I really need to do is come back here, because that was my right endpoint. I just need to take that area, and that area, and that area, okay, which is right endpoint at 6, okay? Right endpoint at 6, that's going to be 369 plus 516 plus 720. The sum of those heights times the width plus what I found in part A, that's going to be 2363 gallons. If I need the under, okay, now I'm using the right endpoint, and I'm figuring the rest of these. Okay, well, now I'm using the right endpoint, which means I need to take my height at 5 right there. My height at 5 is 265 plus 369 plus 516. I'm taking the sum of those last 3 heights times their width plus what I found above to get a lower estimate of 1,903 gallons that leaked after 8 hours, okay? And then what this says is the tanker continues to leak at 720 gallons after the first 8 hours. So graphically, that means after 720, it's going to be a piecewise function basically, and it's going to come together here. And then my function is just going to be straight out 720 gallons per hour constantly from there on out until the tanker is empty. If the tanker originally contained 25,000 gallons of oil, approximately how long will it take before all oil has leaked out in the worst case and the best case scenario? Well, think about it. The worst case is if the oil leaks out really fast. All leaked out fast. Okay, so if all the oil leaks out fast, that's the worst case because more oil is getting in the ocean quicker. Best case is if the oil is leaking slower, okay, slower And that's better. Okay, so how do we do this? Well, we know, what do we know for our worst case scenario? That is oil leaking out fastest. Okay, so in 8 hours, if that much oil came out in 8 hours, right here, oil is leaking faster on my upper sum, isn't it? So what I'm going to do is I'm going to say, okay, in my worst case scenario, I have 25,000 gallons in the tanker, and I know 2363 gallons leaked out in the first 8 hours, and after that, it's going out at a constant 720. This is going to give me 22,637. That's how much is left after my 8 hours, and it's going to leak at 720 gallons per hour from there. That's going to approximately equal 31.44 hours, okay? And how long will it take before the tank has leaked all oil, okay? This isn't all oil. If I add the original 8 hours to it, it's going to be 39.44 hours. Worst case scenario. And if I use what I had up there before, okay, well, I know there's 25,000 gallons. This is best case now, I think. Okay, 25,000 gallons in there. Only 1693 leaked out in those first 8 hours, which means there's 720 gallons per minute after that, or hour. That's going to give me, I don't know, I didn't write it all down, but if I type it into my calculator, that's going to be 32.371 hours plus the original 8 hours. The tanker will be, it's going to take it 40.371 hours. Best case. Okay, in its best case, because it's taking longer for all that oil to get in the ocean. Sorry for the length of the video. I did my best. Have a good night.